Alright, so projectile motion is motion in both the x and y direction, or just two dimensions in general. So we can define x and y, and in our y direction, the acceleration due to gravity is the only acceleration acting on the object in true projectile motion. So that means from our motion equations, delta x would equal v naught x times t plus 1/2 at squared would be 0 because there's no acceleration in the x direction in projectile motion. The only thing that's causing the object to change its motion is that acceleration due to gravity. So the initial velocity in the x direction is the final velocity in the x direction. It's constant the whole time throughout the motion. So our initial velocity in the x direction is equal to our final velocity in the x direction. The acceleration in the x direction is 0. Now remember, acceleration means changing velocity. So no acceleration, no change in velocity. But in the y direction, our acceleration is equal to g, the acceleration due to gravity, which is about 10 meters per second squared for the purposes of our class and the AP exam. Remember, it makes doing the math faster to use 10. So now we can define the equations for motion in the y direction. These look like the free fall motion equations. So delta y is equal to the initial velocity in the y direction, t, minus 1/2 gt squared. Our velocity in the y direction is equal to the initial velocity in the y direction minus gt. And vy squared is equal to v naught y squared plus or minus 2g delta y. So not new equations, just defining them for two-dimensional motion. We can also look at two-dimensional motion where the acceleration due to gravity is not one of the forces acting on the object. And we define the x and y direction. Or it can be x and z. You could even have x, y, and z and have three-dimensional motion, but that's a little bit much. Alright, so for the x direction and the y direction, all three of our kinematics equations will be applicable because we could have acceleration in the x direction or the y direction, or both. So delta x equals v naught xt plus 1/2 at squared, but that acceleration has to be in the x direction. So vx equals v naught x plus a sub xt. And again, the third equation, to a in the x direction times delta x. Now it's important here to put the sign in for the acceleration. Alright, so for the y direction, delta y equals v naught yt plus 1/2 ayt squared. Now I have plus 1/2 because I don't know what the direction of the acceleration is. We have figured out the direction of the acceleration for projectile motion. That's why there's a negative sign there. So if you looked up here, we have that negative 1/2 gt squared, but that's because we know the direction of the acceleration due to gravity. In this case, we're out in space, and the acceleration could be in the positive y direction. Alright, so then vy equals v naught y plus a in the y direction, t. And then the third equation, vy squared equals v naught y squared plus 2a in the y direction times delta y. So most of the problems will have, an object in space is being accelerated, or repositioning a satellite or something like that, where they're both components. Many times you may see the position function written as r of t. This r represents resultant. It means that that quantity may have x and y, or even z components. So for example, you might see r of t is equal to 4 I hat. Now this I hat represents that it's in the x direction. And that's the notation that you'll see. Plus 2. And the unit vector notation for the y direction is j hat. So what does this look like? It looks like this object is at positive 4, positive 2. So there's where our object would be. Or that's the resultant vector. Now it could change position. There could be a velocity. There could be an acceleration. The position could be changing with respect to time. So what if we looked at 4t squared I hat plus 2t j hat? So now the position is a function of time. It's changing. So the first term is in the x direction. The second term is in the y direction. And we don't mix them together. Just like in math class, you don't mix x's and y's or a's and b's together. So the velocity function can be found by taking the derivative of each term separately. So 2 times 4 is 8. T to the 1 less power will be t to the 1. And that's in the x direction, so my I hat denotes the x direction. Now we're going to do the y component. So that was like 2t to the 0, and t to the 0 is just 1, and then j hat. Remember, j is just denoting that it is a unit vector in the y direction. So now I have the velocity is 8t in the x direction and 2 in the y direction. And we can even find the acceleration from here by taking the derivative again. T to the 1 would give us 8 times 1 times t to the 0, which would be just 1. Then I hat. And then remember, this is like 2t to the 0. So 0 times 2 is 0. So there's no acceleration component for the y direction in this case. And that's how to write it as a unit vector. I is for the x direction, and j is for the y direction.